Hello, ladies and gentlemen. Welcome to Math 20-2, Chapter 6, Lesson 2, Properties of Graphs of Quadratic Functions. And parabola cat has an invisible graph. Anyway, the goal is to identify characteristics of quadratic functions and use these to solve problems. Now, we're going to determine with or without technology the coordinates of the vertex of the graph of a quadratic function. We are going to determine the domain and range of a quadratic function, and we're going to solve a contextual problem that involves the characteristics of a quadratic function. So vertex and range. Now, here, a time-lapse camera captured Nicole playing volleyball every 0.25 seconds. Nicole struck the ball at a height of 2 feet above the ground. It took about 1.25 seconds for the ball to reach the same height on the way down. Here's a table of values. So, time versus height in feet. 0, 0.25, 0.5, 0.75. Anyway, so a bunch of questions go with this. When did the volleyball reach its greatest height? We can read the data off a graph. Now, that leads to the question, how do we graph this data? Notice it's not an equation. Well, we've done this before. To graph this data, we must first put the data in our calculators. So, press Statistics, Edit, enter the data in L1, x-axis and L2, y-axis, and y equals. Make sure there are no equations already in the calculator. So go ahead to plot 1. Hit Enter. Graph. May have to change the window settings. Now, poop load there, so let's do that slowly together. For this data back here, this is going to be L1, this is going to be L2. So, as they said, grab your graphing calculator, turn it on, hit Statistics, Edit, and we have some data there already from something else. So clear it, scroll up, hit Clear, and there it goes. Enter the data in L1. Now, I'm not going to flip, actually I should flip backward because I can't remember. 0, 0.25, 0.5, 0.75, 1, 1.25. And my L2 values are 2, 6, 8, 8, 6, 2. Now, I did that kind of quickly, but that's just putting numbers in the calculator, and you've all done that back in Chapter 5, Statistics. Now, double checking makes certain the numbers are correct, because it's really easy. If I miss the decimal and it becomes 25, that screws everything up. Or, yeah, I missed the 2, for 25, I missed the 5, and so 0.2, that will screw the data up. So there it is. I'm going to go back, enter the data in L1 and L2, y equals, next thing, y equals. Now, make sure there's no other equations in the calculator, so we clear this from 6.1. Now, scroll up to plot 1, top, hit enter, and graph. There we go. Now notice we got a bunch of points. Stat plot. Sorry, second y equals gives us the stat plots. We hit this, enter, and we got dots, lines, bar, X list, Y list, so everything looks good there. So clear. Now, the window. Sorry. Now, if we look at the graph, it's like that. So go back to our table of values. Look at our X values. It starts at 0. Remember, this is time. We don't care about negative time here. So my window, come on, should be 0. I'm going to say 2 seconds, and I'm going to put a tick mark X scale at 0.25 of a second. Now, notice my height. We don't have negative heights. So I start at 0, and I'm going to leave it at 10, and there I graph it. I did that quickly, but as I said, I'm more hoping you're following along rather than copying this out. If you're copying it out, then yes, I'm going too fast. Pause the recording. So 0 to 2 for X. X scale of 0.25, Y minimum 0, Y maximum 10, Y scale 1. Graph, and there we go. All right, so there's our graph. Woohoo! That's half the work, and that's most of the work, actually. Now, how do we term the regression function? Well, Mr. Calculator can take that data and turn it into an equation. So it's statistics, calculate, choose quadratic regression. Now, on most of the TI series, that's number 5, quadratic regression. Regression means takes the data, works backwards, or regresses into an equation. Press enter until you get an equation. Put the equation to y1 to create your graph. Make sure to set a proper window. So for here, statistics, scroll over to calculate. Now, as I said, the TI series, usually it's number 5. Where it gets a little confusing is sometimes, okay, X list is L1, Y list is L2. That has to be there. Notice you can get fancy here and have a frequency list. We skip that. Start a reg equation, save that for university statistics. Calculate, enter. Y equals AX squared plus BX plus C. I got A equals minus 16, B equals 20, C equals 2. Or y equals minus 16x squared plus 20x plus 2. And that's what I'm putting in my graphing calculator. Notice this is negative, so it opens down. And it crosses the y-axis at 2. So y equals negative 16x squared plus 20x plus 2 graph. Woohoo! I'm hitting my data points. All right. So there we go. Our graphing calculator is doing the work for us. We've hit all our data points. Now, double checking, go to table of values. Now, I'm going to show you table set. Go up at 0.25 seconds, changing the table. 268862. We are getting the exact same values. Now, that's nice, but you don't need to know that. What you need to be able to do is look at the graph and go, okay, where's my vertex? Because the question was, back here, when did it reach its greatest height? When? Well, my apologies, graph. We calculate, so careful. Calculate that. Actually, let me show you the instructions. At what point in the graph is the graph the greatest height? Second, calculate number 4 maximum. Now, left boundary, see where it says left bound here? You want to be to the left, so scroll over, see this little blinky? Go to the left of the peak, like that. And see the little arrow above it? Now we have to go to right bound. So we want to be to the right of this. Now this is important because Mr. Calculator is stupid. And we have to tell it, look for the peak. And there we go. Maximum, x is 0.6249999949 seconds. Now, I'm going to round that off to 0.625 seconds. 8.25 feet. 624,999, that's 6.625 seconds. All right? So there we go. Now, that leads us to our vertex, the point at which the quadratic equation reaches its maximum or minimum value. Maximum. And in this instance, 0.625, 8.25. There we go. That's what I need. And that should be on the next page. All right, anyway. So far so good. Oh, let's pause the recording here. We'll go into the splash park next. This is a lot, but this is the beauty of the calculator. It lets you find the maximum or minimum, and it lets you find from the equation, and all you need is some data points. So if you've got some data points, like in a science lab, you can turn it into an equation and do all sorts of things with your graphing calculator, which is why I need you to have one. Now I'm going to pause the recording here. If you've got any questions, shoot me an email. Otherwise, good luck. And see you in the next video.